Okay, so we're going to talk about how to find the derivative of exponential functions. Okay, so I gave you some notes and what the rule is, and then we're going to work through a couple examples. So let's work through the first one. It says, all right, f of x is equal to e to the x, and we want to find the derivative. Derivatives of exponentials are super easy. To take the derivative, f prime of x, all right, when it's an e to the x, you copy down your problem, and you multiply it by the derivative of the exponent. So I'm going to multiply it by the derivative of x, and the derivative of x is 1. So that tells me that the derivative here is just e to the x times 1 would be e to the x. And you probably just want to memorize that the derivative of e to the x is e to the x. But that's how you get it. All right, so let's do another one. All right, f of x is equal to 4 e to the negative 3 x squared plus 2. Okay, so again, when you want to take the derivative of an exponential, as long as this is a plain number in front, now in a minute I'm going to stick an x there and we're going to talk about what to do, but as long as it's a plain number there, what you do is you copy your problem down exactly, and you multiply it by the derivative of the exponent. So I'm going to multiply it by the derivative of this. Well, what's the derivative of negative 3x squared? That's going to be negative 6x, and the derivative of 2 is 0, so just get that. Now what I can do is I can always multiply the numbers in the front together. So when I put it all together and simplify, I can multiply that 4 and that negative 6x and get negative 24x e to the 3x squared negative 3x squared plus 2 would be my derivative. Okay, let's do a few more. Okay, so number 3 says, all right, f of x is equal to 6 e to the x cubed minus 3 e to the negative x. Okay, so I've got two separate terms. I'm going to take the derivative of them individually. All right, so when I get ready for the first one, okay, copy it down exactly. And then if I multiply it by the derivative of the exponent, what's the derivative of x cubed? It would be 3x squared. And then I have my minus sign. All right, copy my problem exactly. And then I'm going to multiply this by the derivative of negative x. Well, what's the derivative of negative x? It's negative 1. So, clean it up. On this first one, again, you can multiply whatever's in front of the e to the x and whatever that is. So 6 times 3x squared would be 18x squared, e to the x cubed. All right, now here, be careful with your minuses. That negative and that negative is going to switch it to a positive. And then 3 times 1 would be 3 e to the negative x. Okay. All right. And finally, number 4, before we switch to a little bit harder, f of x equals e to the negative x. So again, this is a real simple one. Copy it down exactly and multiply it by the derivative of the exponent. So the derivative of negative x is negative 1. So if I cleaned it up, I would get negative e to the negative x. Okay. Now, I have a note there, and it says whenever you've got an x and an e to the x multiplied together in the same term, you need to use a product rule. Okay, so let's look at how we do that. All right, x e to the x plus 2 e to the negative 4x. Okay, so what you're watching for is whenever you've got an x in front of the e to the x, that tells you that you want a product rule. Now remember, product rule is 1 d2 plus 2 d1. So let's do that product rule. Alright, so it would be 1, which we're calling x. Alright, d2. So I need to take the derivative of that e to the x. So the derivative of e to the x, I told you to just memorize it, is just e to the x. Alright, plus 2, which would be e to the x, times d1. What's the derivative of just plain old x? It would be 1. Now, we need to deal with this part, okay? Well, since it's just 2 in front and not an x, we just do it like normal, copy it down, and multiply it by the derivative of the exponent. The derivative of negative 4x is negative 4. Okay, so let's clean, and I forgot my prime right there earlier. Let's clean that up. So I would get x e to the x plus e to the x. All right, now if I multiply the 2 and the negative 4, I get a negative 8 e to the negative 4x. Okay, so always watch for that x being in front. All right, so let's do one more of those. This is number 6. F of x equals 3x squared e to the 2x. All right, so again, whenever there's an x in front of that e, you're going to do a product rule. So we're going to call this one 1 and this one 2. So our derivative is, it's going to be 1 d2 plus 2 d1, that product rule from BCal 1. Alright, so 1 is 3x squared. Alright, d2, so to take a derivative of e, copy it down and multiply it by the derivative of 2x, which would be 2. So there's my 1 d2. Alright, now 2 is e to the 2x. And d1, what's the derivative of 3x squared? 6x. Okay, so I'm going to clean it up. So here, I'm going to multiply the 3x squared times the 2. And I would get 6x squared e to the 2x. And over here, I'm just going to kick that 6x on the front. So 6x e to the 2x. Now, when you get to working, you'll notice that a lot of these multiple choice tests, that's not the answer that you see. So you can ask yourself, what can I factor out? What do they share in common? I've got two terms. Well, I know I can take out a 6. They both have a 6. And they both have an x. So I'm going to take out only one x. And they also both have an e to the 2x. So let's take out that from everybody. So if I take that away from the front, the 6 is gone. I still have one x left, and then the e to the 2x is gone. And then if I took it out here, I took away the 6, the x, and the e to the 2x, so there's nothing there but a 1. So if you don't see your first answer, see what you can factor out, and you'll probably see that on a multiple choice test. Okay. Same thing, I gave you a note about using the quotient rule. Whenever x and e to the x are divided together, you need a quotient rule. So let's see. F of x equals e to the x over x. So anytime those are divided, you use a quotient rule. So again, that's something you should know from BCal 1, but our quotient rule is low d high minus high d low over low squared. So it would be low d high, all right, the derivative of e to the x is e to the x minus high. All right, d low, what's the derivative of x? It is 1 over the low squared. So cleaning that up, I get x e to the x minus e to the x over x squared. Now, if all three, I have three terms, two on top and one on bottom. If all three of them had an x, I could reduce it by x, but since that one doesn't have one, there's nothing that they share in common, and I'm going to quit there. Okay, and then finally this one. All right, f of x equals 3x minus e to the 5x squared cubed. All right, so we know from BCal 1, when we have a parenthesis raised to a power, we use the chain rule. Okay, so again, product rule, quotient rule, chain rule, these are something you are expected to know from BCal 1, but our chain rule would be exponent times coefficient, exact same parentheses, but dropped by one power, so I would get to the second. Now, part that everybody forgets in the chain rule is this times the derivative of the inside. So let's take the derivative of the inside. What's the derivative of 3x? Be 3. Okay. And then let's take the derivative of this one, e to the 5x squared. So copy it down and multiply it by the derivative of the exponent, which would be 10x. Alright, so let's do a little bit of cleaning up here. I'm not going to touch the front. Alright, but here I would have 3 minus 10x e to the 5x squared. Alright, so in a chain rule, what I can always do is always take the front and the back and multiply it. So what I'm going to do is distribute this 3 through here just to make it a little bit cleaner looking. So if I distributed that 3, I would end up with 9 minus 30 x e to the 5x squared here, and then I have my 3x minus e to the 5x squared here. So ugly answer, but that's the way you work it. So if you don't remember those rules, make sure you go and review them from B Count 1.